Hello.
Yes, ma'am.
Okay, I will do the roll call first, and again I will take your mm, roll call at the end of my class. Okay, and then I will, after taking a roll call, I will start my class. Now, first is Rupoi to do. Is he present or not?
Yes, ma'am.
Okay, at the end of the class, I will again do a roll call, and that time you have to make your video on so that I can able to see you. Okay.
Okay.
Hello. Now then, Priyanshu, Ranjan,
Yes, ma'am.
Protul Boyd,
Yes, ma'am.
Ashish,
Yes, ma'am.
Shubhodip Bhattacharya,
Present, ma'am.
Parash Hela,
Yes, ma'am.
Shubhomay Viswas,
Present, ma'am.
Shohom Chattopadhyay.
Yes, ma'am. Yes, ma'am.
Okay, fine. Rahul Talukdar,
Present, ma'am.
Prabubdha Mishra.
Yes, ma'am. Present, ma'am.
Okay. Sugato Bishwas,
Yes, ma'am.
Orko Chattopadhyay,
Yes, ma'am.
Saptorshi Mondol,
Yes, ma'am.
Soumodip Bashak,
Yes, ma'am.
Dipon Bourbon,
Yes, ma'am.
Yash, the class. The screen is visible to you.
Yes, ma'am.
Okay, the name of the experiment will be the signal conditioning circuit for capacitive sensor. Now, the here what we are going to do, we are going to use 555 timer circuit for uh, testing the level of a liquid with the help of a capacitive sensor. That means the capacitive sensor is used for a level sensing here. Now, one of the purpose of the signal conditioning circuit is to do linearization. Okay, hold on, please. I haven't start my recording yet. Let me do that. The linearization is one of the technique used for signal conditioning purposes, and there are other signal conditioning techniques, amplify the signal, filtering if the measurement contains some noises, so we have to do filtering. So filtering, amplification, linearization is some of the signal conditioning technique that may be that have been used in when we are going to send some physical quantities if they are produce an output which is non-linear in nature, and if it is contaminated, if the measurement is contaminated with noise, then we do filtering. If the signal output is very low, we do amplification, and so on. So now here in this experiment, what we do, we are using capacitive sensor for measurement of a level of a liquid, And for this, we are going to use a 555 timer circuit to measure the capacitance. And we will see later on this capacitance is inversely proportional to the frequency of the output signal produced by the 555 timer circuit. Now, you have already studied 555 timer circuit in your course, isn't it? Hello?
Yes, ma'am, but it's very
Have
basic.
you studied this circuit in electronics course? Because it must be included
Yes, ma'am.
in your electronics course. Have you studied this?
Yes, ma'am, but that is very basic. I mean,
Yeah,
in the
here
first year
also
class.
I am not going to explain to you the 555 timer circuit. Now, 555 timer circuit can be used in two purposes. One as a monostable multivibrator and another is astable multivibrator. In monostable multivibrator, the single output pulse is being produced uh, from the output of the pin, and we have to given an input to the external trigger input of the 555 timer circuit or 555 timer IC chip. And in case of an stable multivibrator, since it is a free running multivibrator, we didn't require any input. And now, how the astable multivibrator circuit can be used for level sensing, because we will see the the output signal that has been produced by the 555 timer circuit, that is proportional to that frequency of that pulse is proper, or that signal is proportional to capacitance, and inversely proportional to capacitance. Of course, we will see later on that. And then capacitance is proportional to change in the level of a fluid. It may be a water, it may be a conducting fluid. Now, as a whole, we know capacitive sensor. You have studied capacitive sensor in your electrical instrumentation course part A, which consists of a transducer. You have studied entirely several kinds of transducers in your electrical instrumentation course. So we know capacitive sensor, it can be used to measure various physical quantities. It can be used to measure displacement. It can be used to measure pressure. It can be uh, used to measure the uh, level of a fluid. These are the, and if it is measured displacement, we call it to be a capacitive displacement sensor. If it measure a pressure, it is a capacitive pressure sensor. If it is measured the level of a fluid or a water, we call it to be a capacitive level sensor. Now here we are using capacitive sensor to measure the level of a fluid. Now in general, we know that the capacitive sensor uses the characteristics of a capacitor and an electric field to form a sensor. Now, how the capacitor is being characterized? We know the equation of a capacitance C equals to epsilon A by D, where epsilon is the permittivity of the medium, and it is equals to epsilon 0 epsilon r. Epsilon 0 will be the permittivity of the free space, and epsilon r is the relative permittivity of the fluid that has been used, whose level is going to be measured. And then A will be the area, because the capacitor, it forms by two uh, parallel plate capacitors, and the geometric configuration of the capacitors may be different. Sometimes we can use rectangular parallel plates, or we may use circular parallel plates. So the overlapping areas between the two plates, if the area changes, then the capacitance changes. If the permittivity of the medium changes, then the capacitance also changes, and D is the distance between the two plates, isn't it? Hello.
Yes, ma'am.
Now here we are using capacitance sensor as a level monitoring of a fluid, and in conjunction with this, because the level monitoring of a fluid, why we will do this, because level monitoring of a fluid or a liquid, it is a very wide application in industrial plants, in chemical processing plants, in chemical plants, in nuclear fuel processing plants. These capacitive sensors finds an extensive use to monitor the level of a fluid or a liquid. And in general, uh, now if we go on to the, and here we are going to measure that level with the help of 555 timer, because we have seen the 555 timer can be used as an astable multi-vibrator in that case, and when the 555 timer is used as an astable multi-vibrator with the help of some external circuit connected externally to the IC 555 timer chip, we can use to measure capacitance, and that capacitance is inversely proportional to the frequency of the output signal produced by the astable multivibrator circuit. And we will see again later on that this capacitance is proportional to change in the level of a liquid or a fluid. Now we come to the theory. So here I have taken here two parallel plate capacitors. This is just to explain how the capacitance, change in capacitance is proportional to change in the liquid level, to show that, and the configuration may be for different applications, it may be different. The configurations are geometry of the plate. Now here what I have taken to explain the theory behind this experiment, I have taken this is a tank, and it is consists of a conducting fluid in which two identical, and the geometric configuration of the two parallel plate capacitors, it is rectangular, and W is the width of each plate. This is the W, and H0 is the height of the plate or the electrode, and D is the separation between the two plates. Now, when there is no liquid or fluid inside the tank, what will be the capacitance? Tell me. Hello.
Epsilon A by D.
What will be the capacitance when there is no fluid or
Epsilon
liquid
A by
inside
D.
this tank?
Epsilon A by D.
Louder, please. I couldn't hear you.
Epsilon 0 A by D.
And what is A?
Area of the cross section of that plate.
And for this configuration, what will be that?
Uh, that will be H naught into W. No, H.
Yeah.
Yes, ma'am.
Yes,
What?
ma'am.
Into H not into W.
Yeah.
Yes, that's right. So C will be equals to epsilon 0 W H0 by D. And this is the area of the plates. And here, since we have used here rectangular plates, and epsilon 0, now since the tank is filled up with air, before we filled up with a liquid or a fluid whose level we are going to measure. And our purpose is to show that the C is proportional to del H. So it is epsilon 0 WH0 by D. Now we are going to fill the tank with a conducting fluid. Then the value of the capacitance is given by C. What we have taken, C will be equals to this plus this. Do you agree?
Yes, ma'am.
Now, this is the initial capacitance before the tank is filled up with a fluid or a liquid whose level we are going to measure. This will be C0. And when we are going to fill this tank with the help of a fluid or a liquid, we are the final value of capacitance will be this. And then the change in, this is the final capacitance, this is the initial capacitance. So the change in capacitance will be C minus C0. So this will be the del change in capacitance will be equals to the del H, which is the level of the fluid. So the level of the fluid we can measure with the help of the change in capacitance. So is it clear?
Yes, ma'am.
Now this will be the equation of a change in capacitance for an ideal condition. That means we are going to neglect the parasitic capacitances, and we are going to neglect the effect due to fringing. Because if there is a fringing effect of an electric field, we will see that the del C versus is not directly proportional to linear, but the curve will be there will be a non-linearity in the change in capacitance due to the, if we consider the fringing effect of the electric field and the parasitic capacitances, which the capacitances of a cable which is used to connect the components, and also the capacitance of the 555 timer circuit. And we call, due to that, the this change, this proportionality is not being linear, it will have a non-linear effect. So by using signal conditioning circuit, we need to linearize it. And here I have shown how the fringing effect will produce a nonlinearity in the capacitance measurement, and also some parasitic capacitances like cable capacitance, 555 timer and counter input capacitance will affect the accuracy of the measurement. Now, here we are using 555 timer. I have told you previously because it is a IC chip, and it is, the cost is very low. One of the a reason for taking 555 timer to measure change in capacitance, because the 555 timer itself is a very low cost equipment, and the circuit parameters that we or the circuit components that we need to measure the change in the level of a liquid which is proportional to the change in capacitance, that parameters are also very easily available, and they are and their values can be easily changed, and they are also very low cost, and we need simply two resistor and a capacitor besides 555 timer as an IC chip to find out the change in capacitance due to the change in level of a fluid. So we go for this type of circuit. Now timer approaches. Now this we are using. We know that 555 timer can be used in two ways. One as monstable multivibrator, another is astable. Now astable is a free running multivibrator. We didn't connect any input to the timer circuit, and we need only two resistors and a capacitor which has been connected external to the timer circuit. So this will be the 555 timer circuit, acts as an astable multivibrator. Now here pin 2 is the pin 1 is the ground pin. Pin 2 is the external trigger pin, where in case of an 555 timer, when it is used as an monstable multivibrator circuit, we have to put an input to this pin, and 6 is a threshold pin. These 2 and 6 pins are shorted here, and the 7 pin is the discharge pin. I will show whether and this timer astable multivibrator works on the principle of charging and discharging a capacitor. So this pin 7 is known as the discharge pin, because the when the capacitor discharges, it is discharged through this pin 7, and pin 3 is the output pin. From here we will get the output pulses. Now here in our actual experiments, at the output pin we have to connect a CRO to see the signal produced by the 555 timer when it is used as an astable multivibrator. Now it will produce a rectangular pulses, and the it has two modes only, T on and T off. That means capacitor charging and capacitor discharging. Now the 0.8 will be the supply voltage pin. Here we have connected to the supply voltage, which is VCC, and 0.4 is the reset pin. It is sometimes used to reset the 555 timer, but when we are going to use it as an astable multivibrator, we will shorted this pin to the VCC. And pin 5, here we have and pin 1, which is a ground pin, we have connected a capacitor. It will eliminates any noise present in the 555 timer circuit. So, and this will be the internal block diagram. Now how it is works, let me show that how the this diagram is visible to you. Hello?
Yes, ma'am.
Okay, see here, when here the VCC is 6 volt, and from the theory we know that the capacitor will be charging when the voltage across capacitor is less than 2 volt, and the capacitor will discharge when the voltage across the capacitor will be greater than 4 volt. That means when the voltage across capacitor is less than 1/3 VCC, Now VCC is 6 volt, 1/3 VCC is 2 volt. So the capacitor will be charging, and when the voltage across capacitor is greater than 2/3 VCC, 2/3 VCC means 2 by 3 into 6, which is 4 volt, then the capacitor will discharge. And the capacitor will charge through RA, RB, and C. And then the output flip-flop is low, and here, since it is an inverting amplifier, so when it is low, this will be high and LED will be on, because this is a forward bias diode. And when the capacitor is discharging, when it is greater than 4 volt, then this LED here, the output will be high, and here it will be low, and this LED will be on. So have a look so that you will able to know how the capacitor will charge and discharge, and the LED, two LEDs are on and off. So when it is greater than 4 volt, capacitor is discharging. Discharge path is through RB and C. That is why pin 7 is known as discharge pin, and this LED will be on. Now it is charging, so this LED will be on because the output 3 pin is high. So have you seen it clearly?
Yes, ma'am.
Okay. Now this will be the now this diagram is visible to you.
No, ma'am. Actually, your screen share has been off.
Oh, sorry. I have forgotten that. Now is it visible? Hello?
Yes, ma'am.
Okay. So this will have, why my, am I audible? হ্যালো, তোমরা কি আমাকে শুনতে পাচ্ছো?
হ্যাঁ ম্যাম, কিন্তু আপনার দুটো মাইকই অন হয়েছে, একটা ইকো হচ্ছে। যে কোনো একটা মাইক অফ করে দিন।
ওফ, এটা এবার ঠিক আছে?
হ্যাঁ ম্যাম।
Okay, this will be the charging and discharging. Oof, again তো
হ্যাঁ ম্যাম, একটা ইকো আসছে।
ওফ, আমার এখন ওইটা যে ঠিক করতে পারছি না, আমি
আচ্ছা
দেখতে
ম্যাম, অসুবিধা
হবে
হচ্ছে না খুব
পরে।
একটা।
তোমাদের অসুবিধা হচ্ছে না তো?
না ম্যাম, না ম্যাম, খুব একটা হচ্ছে না।
Okay, fine. So this will be the charging and discharging of a capacitor, and this will be the T on and T off time. And when the capacitor charges, I have told you it will charges through RA, RB, and C. So the T on, this is from the theory of 555 timer used as an astable multivibrator. And the discharges through RB and C. So this will be 0.693 RB and C. And the total time period will be T on plus T off.
Ma'am, excuse me.
Tell me.
Ma'am, when the charging has been started again in the second
Again, when the capacitor voltage falls below 2 volt, because when it is less than 1/3 VCC, then the capacitor will charge, and when it is greater than 2/3 VCC, the capacitor will discharge. In this
actually, ma'am,
way, it will goes on and on.
in the output voltage, how that is in on step on the capacitor has not received the 2/3 VCC.
Capacitor will gradually charging.
In ma'am output voltage.
Yes, output voltage will be what I have shown you. So it will, when it voltage across it will be greater than 2/3 VCC, then the capacitor will discharge. This depends upon the two comparators, how the comparators inside we have connected, and the output of from the flip-flop. ওইটা তো তোমাদের পড়ে নিতে হবে, আমি তো তোমাদেরকে বলেছি যে আমি সার্কিটটা এক্সপ্লেন করব না কি করে। when it is capacitor voltage is less than 2/3 VCC, sorry, less than 1/3 VCC, which is less than 2 volt, then the capacitor will charge and charge through R1, R2 and C. And when it is greater than 2/3 VCC, it will be discharge and discharge through R2 and C. চার্জিং এন্ড ডিসচার্জিং এর সার্কিটটা তো আমি তোমাদেরকে শেয়ার করে দেখালাম।
হ্যাঁ ম্যাম, চার্জিং ডিসচার্জিংটা না, অ্যাকচুয়ালি যে আউটপুট ভোল্টেজটা যখন এগেইন 1 এ যাচ্ছে, মানে যখন ওটা
যাচ্ছে মানে
অন স্টেটে যাচ্ছে, হ্যাঁ মানে
0 to 6 ভোল্ট এখানে। this is the on time, charging time is, and this is the discharging time.
ওকে ম্যাম, ওকে গট ইট।
মানে কি বলতে চাইছো তুমি?
অ্যাকচুয়ালি ম্যাম, এখন আমি অ্যাকচুয়ালি ওটা প্রথমে বুঝতে পারিনি, এখন বুঝতে পেরেছি। ওটা মানে আউটপুট যেটা ইয়েটা আছে, মানে টি অন আর টি অফ, ওটা অ্যাকচুয়ালি মানে ক্যাপাসিটরের মানে চার্জিং আর
এটাই
ডিসচার্জিং টাইমটা
আউটপুট
বলছে।
পিন থেকে বেরোচ্ছে। দিস ইজ দ্য আউটপুট V0 ফ্রম পিন 3।
ওকে ম্যাম, বুঝতে পেরেছি।
And this is the voltage across capacitor. You are not going to see this in a CRO, you will see this in CRO. And from this pulse train, you are going to measure T on and T off. And together, T, capital T, which is the time period. And this time period is related with the frequency, which is 1 by F. And therefore, F will be this. Clear? It is inversely proportional to C, and this C is proportional to del H. বুঝতে পেরেছো?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
So this will be the experimental setup. Here, this is the tank, and this will be the L will be the length of the capacitive sensor. D is the distance between them, D2, sorry, and the electrode diameter is D0, and this will be the del L, will be the level of the liquid. And here, this C is equivalent to C test here, or which is the change in capacitance. Clear? Because
Yes,
this C is the capacitive sensor. This C. বুঝতে পেরেছো?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
Now this will be the 555 timer when used as an astable multivibrator. Capacitive sensors is this will be this capacitance will be this one, and RA and RB, two resistors we need, and the VCC here plus 5 volt, and this will be the output pulse train. The same the circuit I have shown you previously, and but RA instead of R1 and R2, here I have written in our experiment it is written as RA and RB, and this will be the actual capacitive sensors, and this is the V0 output, and with this output we are connecting a CRO, and on the CRO we will observe this type of pulse train, and the supply is connected to the plus 5 volt DC. And when the 555 timer chip is provided to us in actual experiment, we have to use Vero board, and there we are going to connect RA, RB and C like this, and to V0 we have to connect CRO, and with VCC with this 4 and 8 pin we shorted it and connected to this plus 5 volt supply. And since this is an actual experimental procedure, and this actual capacitance which is Cx, in theory it is written as C test. It is since we here we have a fringing effect and parasitic capacitance present, so the Cx is not linearly proportional. We have some nonlinear effect on the change in capacitance, and that we are going to linearize. By then that case, what we are using straight line base straight line fit curve, using the method of least square. You have studied this in your numerical programming. There is a course on numerical analysis, isn't it, in your first year or second year?
Yes, ma'am, in first year.
First year, okay. So you have to find out the best fit straight line curve using least square, using these equation. So in experimental procedure, actually what we are going to do, here we have to use RA 100 kilo ohm and RB 47 kilo ohm. And on a breadboard or a Vero board, we make connections like this and pin 3 to the oscilloscope. Then we are starting from the liquid level del L equal to 22 centimeter, and we are going to vary del L. Uh, 22 like this. So, and the time period, this data I have given to you, I will provide you this data, and based on this del L and time period, because since we didn't do the experiment actually, these are the data I have obtained from the experiments performed by the students from their when they do the actual experiment. And based on these two data, so you have to find out the value of the capacitance, and then using that value of C, we are going to use it later on. C mesh will be this. We are del L AT plus B. You have to find out the two values of A and B from the BSL using least square method. Now for each value we have to determine C. And why the inconsistency occurred in a measured value of C, I have told you already. Now in run 2, so here you are going to measure C mesh, and in table 2, the del L actual, these data have been given to you, and the time period you have to calculate. This is from set del L values given in table 2, and for each del actual, note the value of T. Oh, I have to given this value of T and use these measured values of T, obtain del measured AT plus B, because A and B you have obtained from here, and T for del L actual, then you will get del L mesh, measurement value of change in liquid level. Now then you have to find out the percentage error, which is actual measurement of del L, measured value of del L, and the actual value of del L, which has been provided by you in here. I am giving this time period because I have forgotten to put the time period here. Then based on that, you have to calculate the del L measured. So this you have to find out, because del L measured, this you have to calculate it. By mistake I have put the values of this. Okay, and finally I will omit this and then given it to you, because after some modification I will send this to your mail, and you have to submit me a report after a week. That means within next Monday, otherwise I will deduct marks. And then tabulate the results, and you have to draw a curve, percentage first del L versus T from table 1, and also best fit curve on the same figure. Then we have to draw the error curve, which is percentage error versus del L actual, and this error curve you have to drawn by joining the points between 2 points. You have to join it by a straight line. Okay, বুঝতে পেরেছো?
ইয়েস ম্যাম।
ভুলভাল করলে কিন্তু মার্কস কাটা যাবে, এখনই জিজ্ঞাসা করো, এরপরে কিন্তু আমি আর কিছু বলবো না। So what you have to do, you from run 1, del L, it has been given to you, and the time period has been given to you. From here you have to measure C, measured value of C using the formula. Here T is the time period, you know the value of RA and RB, so you can able to find out measured C. Then the del L, which is termed as del L actual value, is given to you, and based on the del L actual, you will get the time period, because for different values of del L, the C values will change. If C value changes, then the time period also changes, and you have to draw the measured values of, you have to find out the measured values of del L using this equation again, because from table 1 you can able to calculate A and B. Take that values of A and B to find out measured values of del L. So this is the measured value of C. This will be the measured value of del L, because here the del L actual will be different from the values of del L here. And then table 3, we are going to tabulate the results del L actual and del L measured, and we have to find out the percentage error, which is given by del L measured minus del L actual and full scale value, because when we are going to find out the percentage error, we have to what we did actually, actual values minus measured values, or measured minus actual, that means test minus true value divided by full scale value, which is the true value. And here, or full scale value, here full scale del L actual, it is taken as a 22 centimeter. And you have to plot del L versus T curve from table 1, and also the best fit curve on the same plot or the same figure, and then percentage error versus del L actual curve. So clear what you have to do?
Yes, ma'am.
Okay. So I will finish my class here, and before that I will note down your attendance again. Now you put your video on so that I can able to see you. Okay, let me stop presenting.
ম্যাম নেক্সট মন্ডে নাইটের মধ্যে জমা দিতে হবে তো?
হ্যাঁ,
ওকে।
নেক্সট মানডের মধ্যে। তোমাদের তো এই ইনস্ট্রাকশনস গুলো পাঠিয়ে দেওয়া হয়েছে, বুঝেছো? নেক্সট সোমবারের মধ্যেই আমাকে সাবমিট করবে।
হ্যাঁ ম্যাম।
আমি কিছুক্ষণ বাদেই পাঠিয়ে দিচ্ছি, আমি তো একটা ডেটা দিইনি, নয়তো ওই ডেটাটা আমাকে দিতে হবে। আমার কাছে আছে, আমি ওটা ভুল করে একটা দিয়েছি আর একটা ওমিট করে দিয়েছি, সেই জন্য অসুবিধাটা হয়ে গেছে, আমি খেয়াল করিনি। ওকে, ফার্স্ট Rupoi to do, put your video on.